Hello, thank you for attending this session. I am Raphaël Faudou from Atos. I'm in charge of R&D method and tools for embedded systems and software. And in this session, the idea is to present the new capability for customization concerning the TOPCASED new modeling editor. By new modeling editors, probably you know that in the recent TOPCASED releases, we integrated the MDT Papyrus UML and SysML editor, and so there are new capabilities of customization with those editors, and would like to illustrate a little bit the usage of those editors in industrial context with a study for the CNES, for the French National Space Agency, and a few slides for Airbus, but as it's quite confidential, we cannot give you pictures and illustration, but give you a few information with Camille. Okay, so let's start with the CNES study. The CNES study, which is the study which was called Generation of Operational Procedure. The problem statement was to define some kind of toolkit to design, check is the important word, import and export the operational procedures through a modeling approach. So operational procedures, this is the way you are going to pilot your satellites. You define it on the ground, and then you will upload it to the satellites and to the onboard software to react on some events. And the idea was to have some modeling approach that would be able to describe the whole systems, because currently the operational procedures are generally defined locally. I would say it means that you have a language to edit them, but they are not connecting to the rest of the system, and that's a problem when you want to do some validation at the end. So on this study, there was a strong focus on validation of the operational procedure in the whole context of the system, with an abstract vision of the system, with different viewpoints coming from, I will give you an example, and connection between all the data of the systems. There were basically two main solutions. First is to use dedicated language for each viewpoint. For instance, if you focus on the architecture of the system, then on the software, the ground segment, the onboard segment, the operational procedure itself, the Fuse services, which is the way you're going to send telecommand and measurement. Well, and the other, but this problem is that when you want to get a final view, the validation, you need to be able to connect everything. So you need to be able to do some gateway between different languages and different tools. And when you are in a context of certification, of qualification, well, if you want to be able to have all the data integrated, you need to be able to do some transformation that can be verifiable. And that's a little bit complex. So the other idea is to use an alignment of your data on a single modeling language. I don't claim here that there is one modeling language to do everything, but the idea is to lay on top of this modeling language as a pivotal language. It was the chosen solution for this study, and we use SysML as a system engineering standardized language, and the TOPCASED new modeling editor to support it. So when you deal with operational procedure, you have standard, and there is some standard from the space industry that precise what is an operational procedure with body and things like that, main body, confirmation, and different blocks that can be refined at several levels. But the most important thing is not to have a language for that. Some already exist and they are okay. The idea is that you can provide references to other elements of your systems. For instance, the space system model identifiers, the procedure is going to be applied on some block on the power subsystem or the ground station or things like that. That's the first point. And you need to be able to have this model if you want to have good right identifier. Second point, you would like to connect your operational procedure with the monitoring and control activities, the event and the reporting data, and there is some standard on that point that precise how things should be managed for these activities. And you would like to put some condition concerning the system modes. safe, nominal or not, and the different modes that you can have for your satellites. Because the operational procedure will not be the same, obviously, according to the different modes. So the first idea was to use UML, SysML, which is the profile for system engineering. The first good news is that if you want to describe an operational procedure, well, you get the activity diagram for SysML, which is not so far. So, okay. If you want to describe the space system model with the ground architecture and onboard architecture, the global system, we get the block definition diagram and internal block diagram from SysML, which is quite close. And, well, the second question is, okay, SysML gives me both diagrams, but if I want to achieve a connection between all those elements, how can I do that? So first, SysML, so one good solution, because it's in the same language, you have the concept, and the concept have been defined to be connected. So you have the glue to connect things from the activity diagram to blocks. And here is an illustration. So, for instance, your designer of operational procedure is going to design his operation, his procedure, and then he would like to address something, an operation on the camera, which is described at the abstraction layer on the high-level description of the space system model. He just used the call operation of the activity diagram that will be linked to the switch-on operation of the equipment. And when you want to describe precisely the switch-on operation at the high level in terms of a succession of fuse operations, I mean telecommands, you can do the mapping with sequence diagram or activity diagram or internal block diagram. So I just want to say that there are possibilities in SysML language to put the pieces together. That's a good thing. No need to do some specific transformation that you need to verify. Okay. But it's not enough, because the end user, they want to address the viewpoint, and they don't want to see the glue of SysML. They don't want to be able to create a lot of elements to connect a block to another thing. So we need to be able to provide some either simplification or specialization for the end user of the space industry. Last point about UML and SysML, if you use the MDT Papyrus editor in the last TOPCASED release, 5.2, you have the possibility to structure the part of your point of view in the structure of your model. And then you have the diagram editor, model explorer, the properties, and the palette. Now let's see how we can customize a little bit all those elements. For instance, I talked about the space system model profile. There is some standard which clearly defines which elements you can use to define your architecture. In that case, we simply define a profile on that, apply this profile on the block definition diagram, and now the end user, he doesn't deal with blocks or parts or things like that probably he doesn't know. He just have to use equipment, assembly, subsystem, which is part of his daily vocabulary that he has to know for space industry. And as soon as he click on this element from the palette, he will have an equipment which is behind the scene a part of SysML, but he doesn't care about that. And on this element, he can find all the specific properties which are not part of SysML native language, which are part of the profile, the redundancy status, on-off status, and many elements that are required by the SSM profile. If we use monitoring and control profile, it is the same thing. We have access to many elements that give access to the observable parameters, operation parameters, all the required elements defined in the profile. And at the end, if I want to now define an operational procedure, we will not show an activity diagram with as many as 40 concepts in the activity diagram of UML. We don't want the end user to be lost in this jungle. So he will find all the necessary elements that are in the specification, in the standard document. So the wait date, wait duration, wait events, stop OBCP, and so on. Those elements he already knows. And behind the seal, those are activity SysML elements which are linked into the model. But we need to provide some simplification concerning the glue, concerning the way we are going to access one element from the other and connect data. So we customize a little bit the property view. The default property view, you get UML, profile, appearance, advanced. And as you can see here, you get, for instance, on your camera, you will have the parameters. It means that you are direct link from your selection, for your camera, from your part of your system to the possible service parameters that are part of the monitoring and control viewpoint. And for instance, the same thing for activities. So you don't need to go to another diagram. You don't need to go through the Model Explorer to check everything. You get direct access, direct navigation through this extended property view. Last point, which is really important if you want to be able to build some kind of modeling language for this at system level, it's the possibility to define rules. Rules because, remember, the main goal was to ensure global consistency to validate your operational procedures. So by construction with SysML, we can have something consistent, but we need to ensure that at the end, everything is consistent. So perhaps that the end user he didn't do the right link, so we have additional rules that we can specify. The first way to ensure consistency is through wizards, quite simple to do. It means, for instance, that when the end user is going to click on the tool for the operational procedure to send a command, we do not let him edit any identifier. We have a wizard where he can browse and he will find only the possible parts that are already been defined in the model. So we know that at the end of the wizard, the model is correct by construction. It has been guided. That's our way, perhaps a little bit intrusive. You may have situation where the guide, he has not already defined the model. So there are other rules that can be applied at posteriori, after the modeling. So it's the thing that you see concerning the mods. In this case, we have a rule, well, the end user is driven by the wizard, and we have some other rules concerning the mods. And for instance, you will have notification, a small pop-up that is going to be displayed, and then that will disappear. But the information will be persisted in the problem view. And that will tell you, okay, you would like to send a command to the different part element, but remember that you specify in your operational procedure some mode which is not permitted. Okay, so we are able to connect all the viewpoints with those elements, either by driving the user or at the end by a small warning to give you the information that he has something to fix. The last part of the study, finally, we could check the consistency at different stages. When we import already existing operational procedures that have been defined in other language in the system database, when we import them, we are able to check all those rules and give something in an error log to tell you, okay, you have just imported your operational procedure. It's consistent at the local point of view, but now with all your system model, it's no more consistent because there is not the right event, the system identifier is not correct, there are things missing in the algorithm, and so on and so on. Then the end user can fix the operational procedure because he has all the links in the toolkit. And so you have on-demand verification or on real-time warnings with the notification. And at the end, when everything seems to be correct, he can do the export and export the operational procedure to the system database again or to another format. And we use the ISIS format for those who know a little bit the CNES. So, as a conclusion, first thing really important is this study demonstrated two main points. The first main point is that we can define a system model with different connected viewpoints that enable the addition of operational procedure in a consistent way by construction and their global verification. So global verification means that you verify requirements, but you ensure global consistency by construction and by all the rules that you added with OCL. So at the end, what is important, you need SysML, you need to have profile on top of SysML to address your different point of view and to align to space standard, which is the vocabulary that the end user knows. And you need OCL, Object Constraint Language, a standardized way to declare, to specify rules on models. And as tooling, TOPCASED SysML editor is a good way to achieve this customization. Profile editor, OCL editor, and checker. Yes, the second way is that if you do that, you need to go a step further and not use some customization to hide the SysML glue, because end user don't want to use SysML directly. And so TOPCASED can give you assistance for that and connect data. But in that case, you will need to do some customization. So the customizing the palette, you can do it by yourself. No need to develop any plugins. Quite easy to do. Without notification and extension of property view, might be a little bit more difficult, but Camille is going to talk a little bit on that point. So as the final conclusion for this study, those are not my words, but the CNES words. This kind of study opens the door for a space domain language based on SysML. It means that if you continue the work, and we will continue this year this work, we can define other profiles for other space standards and then have some kind of space standard language for based on SysML on several profiles. So in that case, we can introduce new viewpoint on SysML, and what if some viewpoints already exist? We can transform existing viewpoints if they are expressed as metamodel or XSD into SysML profile, as there are some possibilities, some transformation that exists between metamodel and profile.
Hi. So I will now give you some feedback from a customization project that we are doing for Airbus. My goal is to give you an overview of what can be easily customized when you are using the Papyrus editors with TOPCASED, what can be done with little more work, and finally to give some improvement ideas for the Papyrus editors. As Raphaël says, the customization project that we are doing for Airbus is the creation of a specialized modeling tool for a specific purpose. I cannot be more precise because I do not have the Airbus permission, but I will be happy to meet you after the talk if you want maybe a little demo and more information. Okay, so the first thing that we have done as in the previous part was to create a profile that defines all the stereotypes for our elements, and those stereotypes extend the basic UML elements. And the first easy customization of the editors was to create a dedicated palette which contains a customized icon. It's quite fun to do in Paint. This palette allows us to create all of our stereotypes elements. But more than that, it allows us to initialize the documentation view with some given pattern for each element. And also to create automatically some UML diagrams for some kind of element when it's needed. The second easy customization was to specialize the Model Explorer view by choosing which UML element we wanted to show to the final user. And also by giving explicit names to the different rubrics of those elements. Because in the Model Explorer view, you have, when it's not customized, you have some nested classifier, some UML language that is not meaningful for the final user. So we now have a solution to create all the elements of our model and a nice way to navigate inside it. And to give you an idea, those customization takes, it's a matter of days to provide a solution like this. But we have gone further than that with a little more work this way. We have entirely specialized the properties view, and the idea was to give an user-friendly interface to fill up all the properties that we have defined into the profile, and to hide all the basic UML properties that are not useful or meaningful for a given element. The main idea is to hide as possible the UML for the final user. Another difficult thing that we have faced was to ensure the consistency between the diagrams into our model, because in this particular project our diagrams share a lot of data and interfaces, so we have to define some function to ensure the consistency between all the diagrams. And based on this problem, the main point was to develop some specific function to make the collaborative work possible. And it's maybe what I've asked a lot of work, the more work. Cool. Here you have an example of what the properties view looks like after the customization. So here we have only the properties that are meaningful. You have some Boolean properties and also the name and the visibility, that's all. And to conclude this talk, I want to give you some idea of improvement for the Papyrus editor. So I think that the work that we have done concerning the property view can be a feature of TOPCASED and the Papyrus editor, because I think it's a need that a lot of projects will need this feature. Another thing was maybe to implement conditional graphical formatting, because the Papyrus editor offers a lot of cool graphical options, but these graphical options have to be set manually. So it's quite, it takes a lot of time to do it, and if you have some, if you want to change the aspect of your diagrams regarding condition, you have to ensure the consistency if you do it manually. So I think we will implement that in the future in our modeling tool. And also maybe to provide, this is what we have done for this project, but it was not a basic feature of TOPCASED. It was to allow to add action when you create an object with the palette. What we have done with the initialization of the documentation, for example. Okay, I think that's all we wanted to present you concerning the customization possibility. So if you have any question, yes.